Hi guys, welcome to the second part of the third module. So in this part we're gonna write a function which will see if these numbers are odd or even. So this function basically, to see that, we have to test um, whether every number before the number 7 is divisible by 7. Okay, I mean, I guess that's the easiest way to find, not the easiest, well, simplest idea to find whether a number is prime or not. Um, we test all the numbers that are less than our key number and see if they're factors. Okay, every number except for one, because one, of course, one will be a factor. So let's insert another module. We'll use a function. So function, we'll call it prime or if prime. Okay, and in this function we need to take an input. We need to take um, a number, so num as integer, and then we need to return a string, which will tell us whether it's prime or not. Okay, so basically what we do is we take this number. So I will do this in two ways. I'll use a for loop, then I'll use a while loop. Okay, so let's do this for loop. So we need a counter. We always need a counter. Dim I as integer. For I is equal to 2 to num. So what this does is it will start with I equals to 2, then it will go up to our number. So we actually don't need to go up to our number because our number is a factor. So we just go up to our number minus 1. Okay, so okay, so basically I like to do this. I like to, every time I write my for, I write my next I, and then just inside I can write my whatever codes I need inside our loop, because this way I won't forget to write the next I. You don't have to do that, I guess. So let's say we're gonna test whether every number between 2 and the number itself is a factor of our number, and if it's not, then it's a prime number. So we're gonna pretend that before anything happens, it's a prime. Okay, equals to prime. So we're gonna return prime if nothing happens inside our loop. So inside our loop, we're gonna test whether our num modulus I is equal to 0. Okay, what modulus does is it actually returns the remainder of a function, sorry, of a divide. Okay, so what this will do is it will divide num by I, and then if we have the mod here, it will only return the remainder. Okay, so for example, mod 6 2. Now the remainder is going to be 0 here, right? What about 6 4? The remainder will be 2 here. Yeah, that's all modulus does. It's very useful in some cases, for example, finding odd and even, and also in here where we need to see if it's a factor. So if it equals to 0, then it means it's a factor. Okay, then we need to return if prime equals to non-prime. Okay, so if this is not true, then if this never occurs, then our prime, we've already set it to be prime. Now notice I can't put this down here. If I put this down here, it doesn't work, because if this happens and the number is a non-prime, then it will run this code and then it will say, okay, it will think the number is not non-prime, and then once the loop is done, it will get up to here and then it will go back to prime. So it's very important you have the order of your code correct. Okay, and everything looks alright. So let's test this. So equals if prime the num. So that's a prime. this is the non-prime, this is the non-prime, this is the non-prime, and that's a prime. Okay? So basically that's how you do it with a for loop. Now, this is actually a very inefficient way of doing it. So think about some ways to make it more efficient. For example, you don't actually need to test up to num minus 1. You only need to test up to num divided by 2. Right? Because you only need to test up to the halfway point. Anything above halfway is never going to be a factor anyways. Yeah? Okay. But we'll just leave it as that for now. We'll just do it like this for now. And we're going to do the while version of it. So there's many ways we can do while. So what we can do is we need to initialize our I first. I is equal to 2. And we need to say while I is less than num. Okay? It's pretty much the same thing. When. Now we need to increment it every time. And then now let's test. If num mod I is equal to 0, then, and if prime is equal to non-prime. So I've actually something went wrong here, right? Because they're not 18 is obviously not a prime. So let's have a look what went wrong here. Okay, so I equals to 2, non-prime. Doesn't seem like anything's wrong here, right? So I can't actually tell whether anything is wrong here. Oh, okay. So I think I know what's wrong here. So in our while loop, what we've done wrong here is we've written the condition wrongly. What we've written is while I is greater than num, then we'll run the code. But you know, I starts from 2. I is not greater than any of these numbers. So we need to actually say, well, I is less than num. So we had it the other way round. Okay? And that's correct. Now this is actually wrong. Right? So 2 is actually a prime number, but it doesn't work here because the problem is we don't have the case for 2. Because oh no, actually sorry, that's fine. 2 is a prime number and it tests the prime number correctly. Okay, so that's how you do it on a while loop. Okay, so you know how to do it on a for loop, and you also know how to do it on a while loop.